And that's how we are recording. All right, so we are going to continue with the part 2 of stress analysis for the pipe that we've been working on earlier on today. So it has showed at different points that my pipe did not pass stress check and weight load, and as well insufficient material thickness. So the first thing I want to do here is to add support. But before I add support and break it into different nodes, let me reduce the pressure. So I'm going to make the pressure 15. Let me make the pressure 10. While I make this one 15. Then I do the same thing for this other end. 10, 15. And the same thing here. 10, 15. This other place. 10, 15. And the last one, 10, 15. All right, so I run analysis. And see. So, continue. For emphasis sake, that's why it's called training. By the time you do it one by one, then someone that didn't get it the first time can get it the second time. So that's why it's being repeated for different times. So you can see that some of the line sections have passed, while some are still showing not pass stress check. And that is node 5, node 7, node 6, and node 4. Okay? So the next thing I want to do now is to add support. Point 5. 1.5. So let's see. Okay, so let's now add our support. So you click, highlight, then insert multiple nodes. So number of nodes we want is 4 at 3.5 meters apart. So we now have different kind of support. Which one do we want to put? Constant support. And we'll say, okay, we have that. So the same thing here. Add support. So it has been preloaded from the last exercise. Said okay, we have it there. So we run analysis. Yes, constant support. On your what? Is there? Is there? So go to output. Okay, so node 5 is telling us something. It says pipes adjoined to this element must have the same properties, which is operation mode. So we need to fix this. This was the same node that was giving us issue the other time. So let's go to help. All right. So see what it's telling us. Can you see? So the error is error 118. Error 118. Pipes adjoined to the element must have the same properties. For all elements adjoining T's and branches, the following properties must be the same: diameter, pressure, temperature, test pressure, insulation weight, blah, 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 blah. This is required for accurate analysis since some properties are based on adjoining elements. If properties must be different, a small intermediate element must be inserted. Okay? And properties can be changed from the subsequent element. So, from this, what do you guys think we're going to do to that node 5? I need suggestions. Mm. Mm. So let's see. So this is node 5, and this is its description. Okay, let's look at node 8. Can you see? It's different. So while this one is not the same as the other one here. So that's why we are having that issue. So what can we do at this point? Huh? We copy and paste. So let's try that. Did it work? Let's see. It did not work. So let's try adding a node. Hit anchor. Then let's move. Let's see if we can move this guy. Get to move it. So what do you think might shift the properties at that node 5? Any suggestion from the house, those watching online? Same.
I didn't get the question.
Why are we having a difference in this node property?
I think it's because the property we're doing differently instead of taking all at the same time. So it will be better we take all at once. That's to highlight the entire pipeline at the same time and then give their properties once.
But the fact that we highlighted it at different time still does not change or make this node not to have that particular property. The reason why we have that is, so let's look at the whole length. Look at the type of support that we have. Let me make it a little bigger. So we must have deformed that elbow while trying to reduce the pressure and running dynamic simulation. Because for this type of support, you can still allow some form of up and down deflection. So that is why, if you see, even in the error, can you see? So that disjoint comes from repeated dynamic analysis. So we have deformed that particular node and we have to try again.
Okay, sir.
So let's go again. So process piping. Yes. The node. We can change the support, but that node is not changing. I tried it earlier on. It will go with other properties. So maybe we'll try that later on, but let's just go this way. 23, 20, 35. Then we have piping. Try deleting it on your own model. Let's see. Before I do this, let me set my unit. Yes, try it. Both of you should try it on this system. Meter, square meter, m raised to power 4, Pascal, Newton, Newton meter. So let's go now. So on our X, we have it as 50 meters. Outer diameter is 0.5. Thickness is 0.05. Corrosion allowance 0.001. 1,500. There is, but it will tell you that it's going to go out with other properties. Click on the node itself and click delete on your laptop. So, material database. It's gone, right? So let's get a new node. Midpoint. Expansion loop. 2 to 90. Anchor support. Everybody should be at this point, at this moment. Then let's share the load. So let's run analysis and see what we have. So this will be 310720-4. Okay, we have a -4-5. Perfect. So you can see that at this point, we don't have any issue with pressure except the pipe thickness. All right. So let's see what it says. Let's go to error 39. So 039. It says wall thickness is insufficient for a given operation pressure. It says strength condition not met. Pipe wall thickness is insufficient to do what? To withstand what? Aha. This warning is also displayed when your thickness is less than the required minimum in what? In standards. And can you see all the standards stated? For occasional operation mode, allowable stress is taken as for test mode, but for operating temperature, If yield stress SY is unavailable for operating temperature, then cold state SY is multiplied by, which we have the formula there. Okay? So with this, what do you think we are going to do? Aha. So we highlight. So what do we have as a thickness? 0.05. Can we make it 0.01? 0.1? Do you have that error message? So what you are going to do is you keep checking till you have one that is going to pass. All right? So keep checking till you have one that will pass, then state it. All right? So for the sake of time, let me teach you something new. What if we want to have a deviation along the pipe? So take for instance, if I have this length, and I want to cause a deviation, all right? I will click on rotate. It says select node to rotate from. I click on 13, and I say, okay, rotate about Z by 30 degrees, and I say apply. So I have that. All right. So let me copy my node. It's stable. Don't worry, you will see it. It's hanging in the air. It's not. It's because of the view you are looking at it from. So watch. Can you see? Yes. Like your pipe, it's just like your pipe taking a bend. That's how I have to show you from up. So this is how it looks from up. Okay. So I go back to my 3D view. And okay. So next thing I want to do is to have an offshoot from a pipe. in this dimension. So how do we do that? First thing we have to do is to do what? Put a node. At this point, I want to make it at the midpoint. I click OK, and it's there. Then I go to my pipe. All right. So you can see I have a pipe with the former diameter distance, but that is not the orientation where I want it. This orientation is, which orientation is this? And I want it on where? Z. Good. So, yes. And I click OK. So can you see that? So it's asking me, do I want a forge T? Yes, I do. Then you now have to set the dimension of the forge T, header length. So anytime you are working on a design, ensure Stafford have made it so easy for you that you just have to look at the diagram you have here to be able to define whatever you have at that point in time. So it's a header length in meters. So can you see this header length L? That's the length of your T. So how long do I want my T to be? Okay. I put, what was the diameter of our pipe? Can you remember? Because the header is supposed to be times 2. Okay, let's try 0.5 and see. Then the crotch height HB is this distance. Okay, so we say 0.1. Okay, so we have that. All right, if you zoom in, so can you see your T? So we go back to fit to screen. Then from here we'll continue the piping 15 to 16. Yes. What direction do I want to go? Do I want to go Y again and Z again? No. Z, X, yes. Positive or negative X? This time we are going negative X. Not even X. You want to mislead me. It's Y. So minus 5. Click apply. Can you see? Then at that place we add cancel. Then I add a stop. And say close it up. Okay. Then I can add my elbow. Short elbow. Okay. And I copy this. All right, so we have that. So if you look at it from top, you have this. If you look at it from 3D view, you have that. If you look at it from back, right? So you can see it from different sides. Okay? So this is supposed to be the second image we look at for today, which is this. So that's the one we just modeled. All right? So I want you to try it on your own and submit before our next class. Any question at this point? Yes. So subscribe for those of you that have not subscribed, because this video will be uploaded to the AIGE Limited YouTube channel, and you can watch it as many times as possible to try this on your own. Thank you for your time. Any question at this point in time? If no questions, have a nice day and see you next time.